Hey everybody, it's Miss Y again. I am teaching you today the lesson on standard deviation, mean, median, and mode, but I want to go over the rules again for those of you who did not see the first video, which you should have. The question I seem to get a lot in emails is whose learning plan are we following, the Hampton City Schools or mine? At the high school level, they gave us the option of using the Hampton City Schools or using our own. So I have decided to use my own. You do not have to do their alternative learning plan. I am putting grades in the grade book, and they will not be factored into your final grade. They don't want us to count them because they feel like it's unfair of us to take your grades and put them in when you don't have our live help. But it doesn't mean that I'm not keeping tab of what everybody's doing. So please stay up with the lessons. I'd like you to attempt everything and send me your questions, no matter how difficult. Give it a try. Really good feedback, and I am adapting the lessons to try and teach to what you guys like. I'm using Zoom, which is a recorded live session of my flip chart, so then you guys can see exactly what I would have taught in class. The only problem is you don't get to interrupt and ask questions, which makes the lesson go a lot quicker. Please try and meet deadlines that I set. So for instance, the lesson I posted 2 days ago, Monday, actually I posted it Sunday night, had a deadline of midnight Wednesday. So you should be meeting those deadlines. The missed testing quizzes that were given before the shutdown do count in the gradebook, and you will have to make those up when you return to school. And please don't share Google Classroom or quizzes links with one another. I found one of my students in somebody else's gradebook, so you guys need to stick with your own links and your own quizzes codes. Do not use each other's. All right, 11, 5, and 6, analyzing data and the standard deviation, and my face is going away now. All right, so the Cameron problem. Cameron asked his classmates how many pets they own. The results are listed below. So one classmate had 1 pet, another had 0, a third had 2, and so on. So for his classmates, what is the average number of pets amongst those 8 people? Well, I added up all those numbers and divided by 8, and I got 1.875 average number of pets per classmate. What is the median? We found the average. Now we're going to find the median. The median is the middle of a set of numbers, and you have to order them first. So I had to put those numbers up here in smallest to greatest order. So 3 zeros, a 1, 2 twos, a 3, and a 7. And there are actually 2 middle numbers. When there are more than 1 middle number, when you have an even data set, you have to average the 2 middle numbers. And the average of 1 and 2 is 1 plus 2 over 2, or 1.5. The most common number of pets, or the mode, would be the number that occurs the most often in that data set, and that would be 0. So if Cameron wants to convince his parents to get him a pet, which of these 3 measures should he report? Well, obviously he's going to want that pet, so he should tell his parents that on average, his classmates have 1.875 pets each, not 1.5, the median, and certainly not 0, the mode. You can do this in Desmos. So what I'm going to do is take this data set, copy it, go to Desmos, and write mean. That's the word for average. I'm going to put that data set inside parentheses, and right there is the mean that we got. You can also do median. And again, put that data set inside parentheses, and there's our median. There is none for mode, so don't even try. See, nothing for mode. But there is one for standard deviation, so I will show you where to go. All of these are in the keyboard tab, functions button, statistics. Mean is up here on the top row, median is on the second row, and standard deviation P is on the 4th row. Do not use stand dev in the 3rd row, use this one. And we'll talk about the standard deviation on the next slide. So, these are the definitions you really need to know today. The mean is called X bar, you say X bar, and it's the sum of a set of data over the total number of values in that data set. The median is the middle value of the data set once you have ordered it from smallest to greatest, and if you have 2 middle values, you must take their average. The mode is the most frequently occurring value, and the standard deviation is a measure of how much values vary from the mean. So for a long standard deviation or a great one, you'll have spread out values, and for a small standard deviation, you'll have very tightly clustered values. If I gave a test on sequences in series to my class, and I have 12 scores to share, what is the mean, median, mode, and standard deviation? So I'm going to copy these values, go to my trusty Desmos, and I'm going to put these right in on top of the other values. I'm just cutting and pasting right over them. So you can see 89.33 repeating for the mean, 91.5 for the median, and 8.55 for the standard deviation. All right. The mode was 92 because I happen to have two 92s in this data set, one here and one here. Now we're going to look at this low value of 67. So remember, these are 12 student scores and somebody got a 67. So what I want to do is find their z-score. The z-score is the number of standard deviations that a data value is away from the mean. So positive z-scores are above the mean. So this is the mean, and this is what we call a normal bell curve. And so positive z-scores would be on this side and negative z-scores would be on this side. So we're going to find the z-score for that grade of 67. The formula is x minus mu over sigma, where x is the test value, that's the 67. Mu is the mean, and sigma is the standard deviation. We talked about that, the spread of values. So we're going to put in 67 minus 89.33. That was what the mean was on this page. And the standard deviation was 8.55. And we get a z-score of negative 2.61. So that would be somewhere over here on the curve. Remember, negative values are to the left of the mean. So the question is, what is the probability that this student gets a 67? So you can use your z-score to find the probability. You're going to take out your tables that I have uploaded in this lesson, your z-tables. And you're going to look up a negative 2.61 by first going down the column that has negative z values until you get to the negative 2.6. And then you cross over so that you're below the 0.01, and that together makes negative 2.61. So the answer to that would be negative 0.0045. So this would represent the area in this curve to the left of this z-score, and that is negative, 0.0045. And that area is a probability that that student got a 67. In other words, there's a very low probability that someone scored that low on the test. All right, I'm going to skip this slide, but I have uncovered it in case you want to check your numbers. And we're going to find out why z-scores are used. So a z-score tells us how far data values are from the mean. And the more extreme, that means higher or lower the z-score is away from the mean, the more unusual it is. So if you were trying to find out who is the better athlete, Emmett, who does shot put, or Reese, who runs the 800, you would want to know their z-scores compared to the other people in their field. Now it's easy for Emmett because all of his data values are in feet. So he has a 43.5 x value, his personal, a mean of 41 feet, and a standard deviation of 3 feet. So we just put all those together and we got a 0.833. That's a positive z-score, and that's good when you're doing shot put because the bigger your number, the better you are. When you're talking the 800, you want to be the fastest person in the field, so the smaller your time, the better you are. So I had to convert Reese's time. He has minutes and seconds for both his score and for the mean, and we need it all to be in seconds so that you can work with it. You cannot work with different units in the same z-score problem. So 2 minutes and 1 second, 2 times 60 is 120 plus 1, that's 121. 2 minutes and 46 seconds is 166. And we use the 15 seconds for the standard deviation. So Reese's z-score is -3. And again, negative is good for his race. Well, which is the better athlete? The one whose z-score is the farthest from the mean, or 0. Z-scores of 0 are the mean. So it looks like Reese is by far the better athlete because -3 is much farther away from 0 than 0.833 is. All right, that wraps up both 11.5 and 11.6. I know it was a whirlwind, so you can go back and pause the video and take a look at those slides if you need to. Now I'm going to talk normal distributions. And we've seen a glance at a normal distribution when we saw this bell curve. So for a large standard deviation, your bell curve is flat and wide. It lowers down and becomes wide. For a very small standard deviation, you have a tall, thin bell curve. This is what's going on in the news right now, and I know you've heard of it, so let me just show you this famous picture. I don't know if you've been watching, but a lot of people are talking about flattening the curve. So this is what they estimate the coronavirus will do if we don't take measures like social isolation, like what we're doing now. This is what will happen to the curve if we do spread out the infectious rate. This line here is critical. Once we've passed this line, then the healthcare system starts to shut down. There's not enough hospital beds, doctors, nurses. So we have flattened the curve. Which curve has the higher standard deviation, the purple or the yellow? The yellow does. It's wider at the base and has a much larger spread across the bottom than the purple. All right, and back to the lesson. I love that I could work that in. You need to know these properties of a normal distribution because one of the SOL questions actually had all of this in it. You need to know that the mean, the median, the mode are all equal and right here in the center. This would be where the mean, median, and mode are. It is bell-shaped, that's this shape, and it is symmetric across this line right here. It never touches the x-axis, it's asymptotic, so even though it looks like it touches, it keeps riding forever in each direction. That's not a good picture of it, but it does. And the total area under the curve is always equal to 1. This is important when we talk z-scores. Here's how you read the z-score table. So again, a z-score of 1.67, the area under the curve is always the shaded area to the left. So if I look up 1.6 and travel over to the 0.07, I get this area is 0.9525. This area, the blue, is 0.9525. So what is the area to the right? Well, because the area under a curve is 1, you would just subtract 0.9525 from 1 to get the area to the right, and that's 0.0475. I'll just pause on this one briefly. You can freeze it if you need to look at it a little longer, but it's the same thing we just did last time. All right, so if I give you a z-score of -2.0, what is the area under the curve to the left, and what is the area to the right? Well, let's do left first. So -2.0, right here. Can you see it's 0.0228? So if that's the area to the left, then I would subtract that from 1 to get the area to the right, a -0.67. Right there, 0.2514. So if 0.2514 is the area to the left, then I subtract that number from 1 and I get the area to the right. Let's do another one, 1.23. So right there, 1.23 has an area of 0.8907, and if I subtract that from 1, I get the area to the right. And a z-score of 0, if you look, the z-score of 0, 0 has a 0.5. This makes perfect sense because if the area under the curve is symmetric, then half would be on the left side and half would be on the right side of a z-score of 0, because 0 is always in the middle. So that's what that looks like. Okay. So we're going to use this z-score, -1.48, and we find that the area to the left is 0.0694. I subtract that from 1 and I get the area to the right, and that's 0.9306. I'll do one more. Actually, not that one. So now I have an area under the curve of 0.2 on the left. So what would it have to be on the right? Well, remember, these two areas have to add up to 1. So this would have to be 0.8. And if I'm looking for the z-score, you realize I'm going backwards on this problem. I need to take the area to the left and find its closest number inside the table, because inside the table is the areas. On the rims are the z-scores. So if I look up the number closest to 0.8, these two numbers are close, but I'm going to go with this one because it's closer. And so my z-score is 0.8 plus 0.04 is 0.84. All right. Now, we are going to use a test value with a mean and a standard deviation to find a z-score and find the area to the left of that z-score. So the x value is 60, the mu is 55, and the standard deviation is 423. And when I do that, I get 1.18. And if you look up, and I'm going to show you what your tables look like. I'm posting this whole document because I couldn't get rid of all of the pages. But if you go to the very bottom, that's the pages you need, those bottom two. So I'm looking up a 1.18. Let's see, 1.18 looks like an area of 0.8810. And sure enough, 0.8810. And I'm skipping that one. Okay, here are your quizzes codes for permutations and combinations. Please use your own class code. Yes, white 5 and 6, I did merge yours together, so you're welcome to use that. That's too many numbers. 1, 2, 3, 4, 5. I have to check that. I think there's too many numbers in this. And your quizzes codes for z-scores are down here. Please use your own codes. Do not jump to another class's. And I think what I'm going to do is post a worksheet or a Google quiz online to make up for this. I'm showing you the answer to the first one. Study it, and then you can take the Google quizzes online for the other 11 problems. So hope everybody's healthy out there and doing well, and that's it for me. I will talk to you guys later. Nope, didn't want that.